All right, today we are talking about a new parent function. This one is called y equals 1 over x. It's called the rational function. Copy that down right now. That is the parent function. It's got two parts to it. And it goes through only two perfect points. It goes through this point, 1 comma 1, and it also goes through this point, negative 1 comma 1, but all the rest of them are decimals. So therefore, you do not have to have 5 points when you make this graph, like you would on a parabola or on a V-shape. You have to have only 2 points, but then you also have to have these things called asymptotes drawn in. So this is an asymptote line. It's a line that is not part of the graph, but it's sort of like a helper line, and it shows you the one number that it can't be. Do you get that I cannot put 0 into this function? Because if I put in 0, I'll have 1 over 0 as my answer, and 1 over 0 is impossible. That's called a hole, not a hole. It's part of the domain that won't work. 0 is not in its domain, meaning that if I try to put in 0, the function crashes. So it'll avoid 0 in both directions. It won't let y be 0, and it won't let x be 0. The reason x can't be 0 is because I put it here, you'll have 1 over 0, and that's not possible. The reason it can't be y being 0, a lot of people don't know this, but there is no way to have 1 divided by something come out to 0. There is nothing you can do to make that happen. You can't have y be 0 because there's no x that would go with it. And now some of you are thinking, what if it was a really, really, really small number or something? No, it would still be 1 divided by this really, really small number. What if it's a really, really, really big number, like a billion, zillion? No, 1 over that's still not 0. There's no way to make it 0. Okay, so if it can't be 0 as x or y, then that means these dotted lines come in. It can't be this way or this way. And these are confusing to remember which one's which. You know the y-axis one, the one that runs right on top of the y-axis? That's not y equals 0. What line is that? This one. I'll put it in black here. That one, that asymptote line. That is not, it's the y-axis, it's not y equals 0. What is it? It's x equals 0. And the other line that runs the other way, I'll do that one in green, for instance. That line, it's on the x-axis, but it's not x equals 0. It's y equals 0. Okay. Those are asymptote lines. An asymptote is, again, something you can get closer and closer to, but it never touches. Doesn't it seem like those are going to want to eventually cross over that asymptote line? But it's sort of like this. Imagine for a moment that you had a glass of water, and you drop in just 1 drop of bright red dye. Drop in a drop. Now the glass turns kind of like a pinky reddish color, right? What if I take that glass and I pour it into a bathtub and I fill it up with water on top of that pinky water? Do you get how it's going to fade out a lot? But is all the pink gone? Is it 0% pink? No, the pink's still there. Just a little bit. It's a very, very small amount. It's not 0 though. No matter how much water you add, it can't ever be 0. Just like this line can never touch 0. It's never going to get there. Even if you put in 100, 1 over 100 is close to 0, but it's not 0. If you put in x is 1,000, it's 1/1000th then. Y would be 1/1000th. It's close to 0, but it's not 0. It'll never be 0.
What about a million?
You put in a million, a billion, unless you start to round, it's not going to ever be 0. Okay, now what if I wanted to move that graph? Let's say I had y equals 1 over x minus 3 plus 5. I bet you can tell the difference. Which one of those is going to make it go up? The 5 or the 3? The 5. The thing on the outside is going to make it go up. The thing on the inside, it's high-vo. It's horizontal on the inside. So that 3 is considered on the inside because it's in the fraction. It's right by the x there. I could put parentheses around it. You really should on any fraction that has a denominator with more than one part or a numerator. Should have parentheses there. Okay, so anyway, it's horizontal on the inside, so that is 3 to the right, and that is up 5. So how would this graph look? Well, you just go like this. Here's my parent points. I'm not even going to draw in this part. I mean, I will, but I'll delete it. Okay, But I take those parent points, and where should I move those parent points? Up 5 and right 3. So I'm going to go take this guy right here and move him right 3 and up 5. Say it's right there. And this point, I'm going to go right 3 and up 5. Say it's about right there. Now, next tip, and this is really important. Pro tip of the day. Put in the asymptotes next. Because after you've got those asymptotes in, can you see in your head where I should draw my shape? From there, it's easy. There we go. There's the graph. It's moved 3 to the right and up 5. You start by moving the parent points, then you put in the asymptote lines, and then you can draw in those things. You do not want to just go, well, it's kind of to the right and up, so I'm going to kind of go like this. Now, that doesn't even pass a vertical line test, so this is not a function. There's all kinds of things wrong with that. But if you're careful, you move your 2 parent points that are always, they start like this, and let's say I move them down and to the right. Let's say they're like this now. Then you need the asymptote lines to keep you straight. The asymptote lines are always exactly horizontal and vertical, and then you can just fill in the rest. Okay? One last thing I want to talk about is how this new parent function can flip. It's weird. So this is y equals 1 over x. What if I throw a negative on the outside? That makes it flip up, down, right? I'm going to make this thing flip up, down. Then it's going to become this part here, flipping up, down. It's going to go like that. And this part here, flipping up, down, it's going to go like that. Do you see how it flipped? But here's the weird part. If I put the negative inside, it's supposed to do a different kind of flip. But do you get if you flip it left, right, it still ends up in the exact same spot? So whether you do a left, right flip or an up, down flip, it's the exact same thing. Now, if you think about this, it makes sense. If I had negative 3/5 or 3 over negative 5, aren't they the exact same thing? So the moral of the story is it doesn't matter where you put the negative on a fraction, does it? Put it out in front, put it on the bottom, put it on the top, all comes out the same. So kids ask me, all right, so this thing's been flipped. Let's say that the question looks like this with the red one. The green ones are gone, just the red one's there. And they're like, well, I know it was flipped, I just don't know which way it was flipped. It doesn't matter. So you can write this as, well, it's obviously 1 over x, that's the parent function of it. And then it has to have a negative somewhere. I don't care which one you put in. Probably easiest to put it right here on the outside. Because if you put it on the bottom, you'd have to put a parenthesis around it. You know what I mean? To try to show it was on the bottom. All right. So I personally probably just go like that. All right. So because your iPads today died, I have worksheets for today. And we're going to do some practice on this. I don't think I need to make up any new problems. So we can actually do some of these. So I'm going to pause the video for a second while I hand these out. Oh, and there's one more thing I got to talk about, domain and range. So remind me in a second once I get these worksheets to you. You know what? Before I do the worksheets, because as soon as I give you the worksheets, some of you won't listen anymore. All right, domain and range. On this thing, I want you to pause for a second. I want you to shut your iPads and just stay with me 100%. No writing, even on paper. Okay, domain and range. Domain is left, right. Range is up and down. So do you get that this thing goes forever to the left and goes forever to the right? Would you agree with that? Then is there something along the way between negative infinity and positive infinity that it can't be? 0. Because if I put a 0 in, see how I get 1 over 0, and that's not okay. It's impossible. So this domain has an empty spot, like a place that it can't be. You can be anywhere in here, but right there, it can't be that. And it can be everything else. So if you wanted to make a number line for the domain, it would be like this. Everything works except 0. You get what I'm saying? Now, how would you write that a different way? You might say from negative infinity until 0 it works, and then it stops working at 0, and then it goes from 0 to positive infinity. And so that's another way to write everything works except 0. There's a third way to write everything works except 0. All real numbers except x cannot be 0. All real is the big R thing that stands for all real numbers. That's 3 okay ways of showing me what the domain is. Okay, in pre-calc we pretty much focus on this way, but I kind of like the number line with the 0 empty on it. That works too. This is more rare, but it's okay too. So all 3 ways are okay for now. That's the domain. The range is exactly the same. It goes from negative infinity down. It goes to negative infinity up. But there's a spot along the way that it can't be, which is at 0. All right, now that most people get, okay, so it can't be 0 either direction. But what if I move it? What if it looks like this? My 2 parent dots are like here and here. I have asymptotes going like this. Now what am I supposed to say for the domain and range? Well, let's say I'm at 3 right here, and I'm at 4 right there. You got to think carefully, what can't it be on the left-right versus the up-down? So the domain is left-right. It goes forever this way, goes forever that way, but there's one thing it can't be when it comes to left-right. 3. It can't be this. See, that's the line that it can't touch. So it's everything except 3. So I'd accept this, or I'd accept this. Negative infinity up to 3. Doesn't work at 3. And then 3 to infinity. Either one of those is good. More rare, but okay. All reals, x cannot be 3. That's the domain. 3 ways to write it. Range. Everything works except what? 4. Because it goes forever down, it goes forever up. But along the way, there's this, and that's at 4. And so it can't be 4. I think my favorite way of writing it is like this. Can't be 4, can be everything else. Okay, that's domain and range. All right, that's all you need to know for that. Now let's do some problems off this worksheet, and here it comes. I'm going to make it a little smaller. You can skip F, H, and I. F, H, and I. Sorry. Isn't it kind of freaky cold lately? I mean, this feels like January weather. It's just weird. Yeah, I mean, I think part of it is you get used to certain temperatures. Global coldening, yes. All right. You may skip F and H and I. That is correct. Okay, let's do A as an apple. So can you agree that that thing has been shifted 1 to the what? Left. 1 to the left. So the parent points on it would have been here and here at 1, 1, negative 1, negative 1. And I have to shift them both 1 spot to the left. So I'm going to shift this to the left and this to the left. My new parent points are the black ones then. Then I would go asymptote lines and then draw it in. Going through my 2 parent points, which are there and there. Make it. Okay, so there's your first one. And could you use an XY chart? Absolutely. Let me just, for 2 seconds, because some of you guys are going to want an A on your next test. If you really want the A, you better take a moment on the few graphs that we have. There's only like 6. Okay, but all it takes is you to screw up 1 extra problem on one of those graphs because it's the smallest test, and all of a sudden your grade drops from an A to a B. Okay, I would take a moment and check just a couple points on the XY chart. Like if I put in this one, it's one of my parent points, so it'd be smart to check that one. I'm going to check if I put in x as 0, what happens? Well, the equation looks like this, 1 over x plus 1. And if I put in a 0, I put a 0 in right there, do you see that I get 1 over 1, which is 1? And is 0, comma 1 on my graph? Yes. So I must be doing it right. This will keep you from making mistakes. I'm telling you, it's a really powerful method. Now if I stick in -2, if I stick in -2 here, I can double check and make sure what happens. Oh, that's 1 over -1. That makes -1. -2, -1 better be on my graph. And it is. So obviously, if these 2 points are matching up, then I'm doing it right. Just takes a second, and the XY chart can save the day. Yes, sir? For the domain thing, let's do the domain and range on this one then. Okay, would you agree domain is from left to right? And how far left can it go? Forever. How far right can it go? Forever. But as you're moving from left to right, what's the thing on the x-axis? Remember, domain's about x's, right? What's the thing on the x-axis that it can never be? Yep. So it's all real numbers except x cannot be -1. Or you can make a number line and say that can't be -1. Or you could say from -infinity to -1, union with -1 to infinity. For right now, as you're learning it, all 3 are okay. When you get to be all grown up, I would do this one. That's the way you're going to use it in pre-calc most. The intervals. All right, that's domain. Range is from low to high. How low does it go? Forever down, -infinity. How high does it go? Goes up forever, so +infinity. But along the way, something on the y-axis it can't be. On the y-axis, that's this axis right here. The thing it can't be is right there. It can't be 0. So all reals except it cannot be 0. Or number line, here's a 0. Can't be that. Or -infinity to 0, union with 0 to infinity. Okay. That's an example problem. And let me just look. The backside's just matching, so that's easy. All right. That's all I have for you for today.